There are different ways in which we can introduce caching into an application architecture. These are the different caches which we are going to see in this particular video. Feel free to skip to a particular section if you are interested in knowing only about a particular cache. The links for the timestamps are present in the description below. I'll be explaining each cache along with its benefits so that you can decide what type of caching methodology you would want to use in your architecture. A disclaimer: the databases, caches, or the use cases which I'm going to show is just for a reference. Be wise in choosing the right cache and the right database which fits your use case. The most common cache which we all use is the embedded cache. Embedded cache is used in applications where we need to do some mappings or reference lookups, which could be adding more load to the database by interacting with the database very often. In order to reduce the latency between the application and the database, we try to get a copy of the data from the database and put it in the application in the form of cache. In an embedded cache, we try to take a copy of the data from the database, keep it in the application, and use it for reference mappings or for private information. There could be a case where we want to have an application specific cache within that particular instance. You can use embedded cache in that particular scenario. Or when we want to have mappings or transformation logic which depends on some specific mapping parameters, you can definitely use embedded cache in that particular scenario. The next common cache which we all use or know is the client server cache. As the name suggests, client server cache follows a client server architecture where you will have application, you will have a database, and the cache is between the application and the database, and it acts as a server for the client or the application. If you compare this with the embedded cache, the cache has now moved out of the application and it is placed as a separate instance which we can connect from our applications. Most of the time we use these kind of caches when we want to have multiple applications interact with the same cache so that we can reduce the memory used in terms of embedding these caches inside each application. That's why we have taken the cache from inside the application and kept it as a server where clients can interact and retrieve data from the cache. Most of the time we use client server cache when we want to have shared caches and also have standalone caches which can be separate from the application. This kind of pattern enables us to distribute and scale much better, and that's when we go for a distributed cache. Distributed cache, as the name suggests, when we have multiple applications retrieve data from a server cache, we need to have multiple instances of the cache in order to serve multiple clients. That's when we go for a distributed cache, and there could be multiple nodes where different instances of the cache are deployed and they are served for our applications. So where do we use distributed cache? Distributed cache is very popular when you want to have low latency and high volume transactions to be processed and retrieved using a cache. One other type or variant of a distributed cache is embedding the cache within an application and interacting with the other application which just got deployed or which needs to be auto-discovered. So the cache is distributed and it is shared between two different applications, and these are embedded. So it's a flavor of embedded cache and a distributed cache within the ecosystem. The distributed cache again leads us to a challenging conversation on how can I add scalability when I want to dynamically scale up and scale down my caches. That's when we move to a cloud cache or cloud service provider managed cache. These caches are managed by the cloud provider. For example, let's consider AWS. We have multiple applications running inside EC2 instances. We have a database which is hosted on Amazon RDS. We want to introduce caching layer. So Amazon provides something called Elastic Cache, which can be leveraged by using Redis or Memcached. So we can have a cache which is a server cache which will be managed by Amazon, and we don't have to manage it, and we can leverage services like Amazon Elastic Cache to provide the caching information, and it is again distributed as well. You can merge distributed cache, client server cache into one and have scalability added into it and move it onto the cloud, and that's what is a cloud cache. So the biggest advantage of using a cloud cache is these caches need not be managed by us it will be managed by the cloud provider, and also it is extremely scalable because we don't have to worry about the infrastructure. One uncommon cache very less people use is the reverse proxy cache. These caches are useful when you want to have your responses cached from your application tier. Let's consider this example. We have application instances, we have Amazon DynamoDB, which is a document database. Imagine we have data stored in the form of JSON in a NoSQL format. These JSONs are retrieved and then pushed onto the client, and we need to cache those responses from the load balancer or proxies. So in this case, I'm just showing a proxy. This proxy could be a proxy like Nginx or Envoy. So the request is going to come to our load balancer or the proxy, and the proxy is going to connect to the application, retrieve the data, and then send it back. If we cache the responses along with the proxy, we call this the reverse proxy cache, where the cache is stored inside the reverse proxy, not within the application. So unlike our client server cache, where we had a separate instance which managed or maintained the cache, here we are going to use the load balancer to have the cache. That way any new requests are going to be returned from the reverse proxy caches. This is one uncommon cache which generally people use it when they use API gateway kind of a pattern, and they don't want to bombard their client instances with much load. That's when we can use a reverse proxy cache. The advantage of using a reverse proxy cache is we can cache the API responses, so it's easy for the load balancer to serve the response because it's already cached, and also we don't have to specifically maintain the cache because the cache is present inside the load balancer or the proxy layer itself, and we don't have to recompute or retransform or map any data which we would have framed during an API response. There is one other popular cache which people are using these days. It's called the sidecar cache. So sidecar caches are very common in the Kubernetes space or the container space. Let's take an example of a Kubernetes cluster. So imagine that I have an EKS cluster. So inside the EKS cluster, I have multiple instances of my application. I also have my data stored inside Amazon RDS. All my containers can be grouped as pods inside the Kubernetes namespace. And I have 3 different pods. Within a pod, now all my applications are running as a separate container. Now if I want to introduce caching, I can have a separate container which can be running as a separate instance but within the pod, and that can act as a sidecar. So this pattern of having a sidecar container as a cache is called as a sidecar cache. Again, this is very popular when we use containers and you want to have cache outside your application. It's exactly similar to a client server cache, but the server is specific to your client. So if a pod crashes, that whole cache is also evicted or cache is also destroyed, and a new pod is going to be created. You will have to populate the cache again. So this is common when we have to have low latency between your cache and your application behaves like a client server kind of a technology. So the advantages of using these kind of caches are containerizing the caches are easy, and if you have containerized environment, it's easy to containerize your cache. You will have low latency between your application and the cache, and also you can have your application isolated from the data in the cache. One another common feature is the polyglot functionality, where your application can be in a different tech stack and your cache can be in a different tech stack. This leads us to the newer service mesh concept, where we are going to merge both the reverse proxy and also the sidecar cache and create something called as reverse proxy sidecar. If you have known what is a service mesh, this is going to be easy to understand. If you don't know what is a service mesh, I would suggest you to take a look at my video on what is service mesh. So in order to deploy applications and easily manage in a Kubernetes namespace, we will have to deploy different containers within a pod. So let's take the same example. We are going to have multiple applications and we are going to have a reverse proxy. So this reverse proxy or the proxy could be similar to an Envoy kind of a proxy. So Envoy is a very common proxy which is used within the service mesh space, where you call this as a data plane, right? And control plane is the EKS clusters managed control plane. Imagine this particular proxy is going to be sitting with the application within the same pod. So we have 2 containers within the pod. This pattern is called as a sidecar pattern, and one is a proxy. So every request coming into the application will have to come to the proxy, and the proxy will send the request to the application. So you cannot bypass any call to the application directly. Instead, you will have to come to the application via the proxy only, and this is the sidecar pattern. We have multiple instances of these pods running in the cluster. Now, in order to cache, if you remember the reverse proxy cache, what we said is we will be caching the data from the application into the proxy itself, and that's what we are going to do. So we have, let's say, the same database, Amazon Document DB, and we are going to cache the API responses which the application is going to return, but we are going to do that in the proxy layer. So we will be caching that in the Envoy or an Nginx kind of a proxy which is going to run along with the container. This kind of a pattern is called as reverse proxy sidecar cache. Obviously, since we are merging two different patterns, it's going to bring those advantages to this particular pattern, which is the low latency between the cache and the application. The API responses are going to be much faster because you do not have to reframe or reiterate or retransform your data and then send it. There is isolation between the application and also the data. Your requests are not going to reach your application because the data is cached, and the cache is going to be returned from the proxy directly, right? And there is no application specific maintenance which is required in terms of cache. We don't have to even code anything for caching inside the application because the cache is present outside the application code. Since there are so many caches, now what are my design considerations which I need to identify and take care when I choose a cache? So the first and the foremost thing is the lifetime of the cached data. So we need to identify how long a data can sit within a cache. Let's say if we have a client server cache, now the data is in the cache. Now how will I sync that data, or how long will that data be consistent with my database, right? So we need to have a lifetime for each cached data so that we can identify when the data should be refreshed, or is it instantaneous, or we have to manually remove it and then update it. This brings us to the next consideration, which is called the cache eviction. So we need to remove data from the cache if it is stale, and that is called as cache eviction. So we need to remove unstale information from the cache. We might not have data in the cache. We might load the data using lazy loading, but still we will have to remove the data from the cache if the data is not going to be consistent after a period of time. The next consideration is consistency. How consistent is our cache with the database? Is it going to have eventual consistency, or is it going to be instantaneously consistent? Those kind of considerations will also impact your design decisions because your cache needs to be always consistent. The final thing is, how do I prime the cache? This is basically loading data into the cache and also evicting data from the cache. How often should I load the data into the cache, or who is going to load the data into the cache, or how is the data getting loaded into the cache? Those are some of the key design decisions which we will have to consider in choosing a cache. I hope you had some good understanding of the different caching mechanisms and also some of the considerations which you will want to think while designing or choosing a cache. If you think there are more caching patterns, do let me know in the comment section below. As always, if you like the video, go ahead and like it. If you haven't subscribed to the channel, go ahead and subscribe to it. Meet you again in the next video. Thank you very much.